Okay, so we are going to start our first section of recorded notes, section 6.1. And just a couple of reminders. You are encouraged to pause when you need to catch up, to replay. If you didn't catch something, you might want to replay the video to get a better grasp of what was being taught there. Another suggestion is to either watch the entire video, then take your notes, or maybe take your notes while watching it and then watch it a second time, just paying attention to what's going on. You may need to rewatch these videos to fully understand. So you're going to follow along. The expectation is that you fill in the note outline with everything that I put on the board. There may be extra examples that I don't choose to do. You're more than welcome to do those. They will not be required to be done on your own. So the only thing that we'll be looking for a notebook grade is that you have everything that we did on the board completed. At the very end of the lesson, we ask for 2 extra things. We ask for a lesson summary, and then we also ask for a problem. So you're going to do 1 problem on your own, and that should be done when you get to class to get full credit. And it just gives us a chance to give you some one-on-one feedback before you start your assignment in class. So those are all the things that we'll be looking at when you come into class Monday after break for this particular lesson. So before we begin systems of equations, today's day is solving by graphing. And so we want to do a quick little graphing review. And at the very top of your notes, there's a review section that asks you to graph the 2 equations on the same coordinate plane. So the first equation is already in the form y equals mx plus b. So y equals negative 1/3 x plus 4. And just to quickly review that it's in that form, that means the slope of this line is negative 1/3, and that the y-intercept, or the little b, is 4. And so we just simply start at 4 for our graph, and then a slope of negative 1/3 tells me we're going down 1 and 3 to the right. Down 1 unit, and we run 3. And then you can connect all 3 of those points, and there is your line. You can also make a table of values, but this is the easiest way. So using slope and y-intercept when we graph is a great tool. The second equation that's given, 2x plus 2y equals 8, is not in slope-intercept form, so we need to get it in slope-intercept form. So we need to rearrange things using inverse operations. So we're going to subtract 2x from both sides. By doing that, the 2x leaves the left-hand side. We're left with a 2y on the left-hand side. And then an 8 and a negative 2x do not go together, so we'll just simply put the negative 2x out in front of the 8. We're almost there. We just got to clean up the y. So y is being multiplied by 2. We're going to divide every term by 2. And so that leaves us with a y equals negative 1x plus 4. And so on this graph, we have, again, our starting point is going to be positive 4. And then now my slope is a negative 1. So we're going to go down 1, 1 to the right, and put another point. Down 1, 1 to the right, put another point. And then we connect and extend. So we'll be doing the same thing today, but after we graph. More importantly than graphing is we're going to look at the relationship between the 2 lines. So that was just a quick review on graphing in itself. So a system of equations, this is the whole entire chapter 6 is involving a system of equations. And you guys can read the definition, but in a nutshell, it's when you solve 2 or more equations with 2 or more unknowns. So you're going to solve for an x and a y at the same time. If you have 2 unknowns, you have to have 2 equations to go along with them, 2 relationships. And so the whole chapter 6, we're going to explore all the different ways to solve for 2 unknowns at the same time. The first of which is graphing. It's not my favorite, but it does give a great visual of what's going on in a system of equations. So underneath here are the three possibilities of when you graph two equations on a coordinate plane. So since we have an x and a y unknown, we can graph it on a coordinate plane. Two unknowns, two number lines, we have a coordinate plane. And so we're going to go through all the different possibilities of what can happen when you graph two lines. So when you graph two lines, you can actually get two intersecting lines. And the solution to this system is the shared ordered pair. A solution to a system of equations is the ordered pair that works for both equations. So it's the intersection of the two lines. This ordered pair here, which is 2, 4, is a solution to the blue equation, and it's also a solution to the red equation. And so up above in the definition of systems, that's how you determine a solution to a system. It's the number combination x and y that works for both equations. So the intersection would be the solution. So this particular system has one solution, exactly one solution. Lines cannot come back around and intersect again. So one solution, and then you name it. You actually give the solution, and it's an ordered pair, 2, 4. We also have a name for that solution or that system. It's a consistent and independent system. It's consistent because we got an answer, and it's independent because there's two separate lines. It just tells a story about how you get that information. The next possibility is when you graph two lines and they're parallel. If they're parallel, they'll never touch, they'll never intersect, they'll never share a common answer. And so parallel lines have no solution. A system of parallel lines. All the ordered pairs that work for red only work for red, and all the ordered pairs that work for the blue equation only work for blue. There is no solution that works for both of them. And so we describe that as an inconsistent system. There's no solution. So it's not consistent, and that's inconsistent. The third possibility, which is hard to see, is showing the blue equation. But actually what they're showing you here by only showing you one line is that the other solution or the other graph is right on top of the blue or underneath the blue. So the red equation and the blue equation actually end up graphing the same exact line, which means every ordered pair that's found that works for the blue equation also works for the red equation. So there's an infinite supply of ordered pairs. There's not just one ordered pair. Every single ordered pair works for both. So we call that an infinitely many solutions. We'll never run out of solutions because it goes on forever and ever. We got a solution, so it's consistent. But instead of being two separate lines, because it's the same line, we call it dependent. So consistent and dependent. So on the next page, I just kind of go through it again, and I didn't really scramble them a whole lot. So if you look at number one has one solution. We can actually name that solution. That solution is the ordered pair 3, 1. I went over 3 and up 1. That means 3, 1 is a solution to the first equation, and 3, 1 is a solution to the blue equation, both red and blue. This is a consistent and independent system. Second scenario, they're parallel. This is a no solution, and we call that inconsistent. And the third, there's only one line showing, which means the other line is also there. This is your infinitely many. You can't name them all, so you just tell me there's an infinite supply. Whatever works for the one will work for the other, and we call that consistent and dependent. So if they ever ask you to describe the solutions, that's what they're looking for. The inconsistent, consistence, independence, dependence. To answer, to solve, is the other three answers. An ordered pair, no solution, or infinitely many. So that's your only options for your homework today. The ordered pair will change, but those are your only options. All right, let's go ahead and try this. So we're going to solve it, we're going to graph it, and then we're going to interpret the graph. So the first equation here, y equals 2x plus 3, is already in slope-intercept form. My slope is 2, my y-intercept is 3. So I'm going to start at the graph at 3, and then I'm going to count up to slope over 1. Up to slope over 1, and I'm going to be very careful to connect and extend in a nice straight line. You really want to be accurate here, because you're not just sketching a line, you've got to figure out where these two lines intersect. So the more accurate you are, the more luck you're going to have here. So I highly recommend graph paper. We'll provide that in class. And then also maybe a ruler if necessary. The next equation needs some work. So I'm going to take this next equation here, this 8x minus 4y equals negative 12, and I'm going to clean it up. I'm going to put it into slope-intercept form. So the first thing I need to do is subtract 8x from both sides. Okay, the 8x goes away from the left. Negative 4y equals negative 8x minus 12. I'm going to divide by a negative 4. I'm getting the y value by itself. Y is equal to a 2x plus 3. So for my red line, my slope is 2 and my y-intercept is 3. So I'm going to start at a y-intercept of 3, which was my same as my blue. And if you notice now, you can see that it's the same exact equation. Y equals 2x plus 3 is the same as the blue, y equals 2x plus 3. So it's the same exact line. I don't need to see you graph it twice. I'll just show you that it's going to line up the same. Okay? And so you didn't really know that going into it, that was going to happen, because the second equation was a little disguised. So now that we know what happened, we have the graph. The graph is part of your proof and your work. So now we're going to interpret the graph. The graph is not the solution. Your interpretation of the graph is a solution. So this tells me that we have infinitely many solutions. And then I'm going to describe it. I did get a solution, so it's consistent. But it was the same line, so it's dependent. So consistent and dependent. That's your answer. I know that because I can show you the graph, and I know that graph works because I have all my work supporting it off to the side. All of it tells the whole picture here. Let's try another one. The next problem here, both of these equations need some help. So actually, I do have to correct this for you real quick. On your notes, it's right, but on mine, it's incorrect. So this is just an x here. Let me just clean that up. X minus 2y equals 4, and x minus 2y equals negative 2. So the very first line, this first equation, I'm going to clean it up and put it into slope-intercept form. I'm going to subtract x from both sides. That gives me negative 2y equals negative x plus 4. I'm going to divide everything by negative 2. And so that gives me y is equal to a positive 1/2 x minus 2. So my first graph, I'm going to start at negative 2. I'm going to go up 1 for every 2 that I go over to the right. Up 1, run 2. Rise 1, run 2. Connect and extend those points. That's my first graph. My second equation also needs some help cleaning it up. So I'm going to subtract x from both sides to move it to the right-hand side. Negative 2y is equal to negative x minus 2. I'm going to divide everything by a negative 2. And I end up with y is equal to 1/2 x plus 1. So this equation starts at positive 1. My y-intercept is positive 1 and has a slope of 1/2. So I'm going to go up 1, run 2, up 1 over 2. That's the same exact slope as the last equation. If you remember from, I believe, chapter 4, last chapter, We talked about parallel lines. Parallel lines have the same slope. So before I even started graphing here, I had told you that they had the same slope, but they were going to be parallel. Okay, that doesn't mean you get to skip graphing them. The graph is telling the story. That's part of your work. You're not done yet. If you just graph the two lines, if you tell me the two lines are parallel, that's still not answering the question. You are asking for the values that will work in this system of equations. And the answer is, there is no solution. There's no solution to this, so it's inconsistent. I will show you, when we finally get an answer, how to check your answers in a system. What this means is that the only ordered pairs that work for red only work for red. The ordered pairs that work for blue only work for blue. There's not a shared ordered pair. Okay? We got one more, and we got one more correction here. I didn't like these equations, so I'm going to ask you guys to change them as well. Okay? Sorry about that. We'll make it better next year. So y is equal to x plus 4 is the first equation. And then the second equation is y is equal to negative x minus 4. See, I made nicer, easier equations for you. So let's talk about the blue equation first. Okay, I'm going to make this one my blue just to help match it up. I'm going to start at 4. It's already in slope-intercept form. So I have 4, and then my slope is a positive 1. This is really a 1 over 1 slope. So I'm going to go up 1, 1 to the right, up 1 over 1, up 1 over 1. And if you're going to continue, you might want to continue your points if you don't have a ruler, just to make sure that you're accurate. You really don't know where it's going to cross. So you might want to do more than just a couple points to be accurate. That's my first line. My red graph has a y-intercept of negative 4, and it has a negative 1 slope. So I'm going to go down 1, 1 to the right, down 1, 1 to the right. Well, I'm not going to hit it if I keep going in that direction. So I'm going to switch directions and just continue going up and to the left until I actually cross that line. So you may need to extend just a little bit just to make sure that your lines are accurate and they cross at the right spot. And so we can see that this ordered pair right here, which is negative 4, 0, is my solution. Negative 4, 0 is the ordered pair that shows up on the red graph and the blue graph. When I plug in negative 4, 0 into this first equation, 0 equals negative 4 plus 4. Yep, that's true. 0 is equal to 0. And in the second equation, 0 is equal to a negative 4 minus 4. Sorry about that. And that is also true. It gives you 0 is equal to 0. It's a solution for both equations. That's how you can tell that it's right. So you can plug it into both to check it. It has to work in both equations. And so this is a consistent and independent system. And that is how you graph systems of equations, or solve by graphing. So here's that last part of your lesson. I'd like you to come into class tomorrow with a summary of what you just learned. Put it in your words. You can go outside the box, obviously, if you need more room. If you have a question, if there's something that's standing in your way of understanding, watch the video again and see if it's still there. Be specific, a specific question. Where did you get slope? How did you get a 2x? Give a question or a problem with something. Okay, or maybe state something new that you learned that you didn't know from before. Maybe you just figured out how to put an equation from standard to slope-intercept. You can state that in there, okay? It just lets us know that you were actually involved, actively learning when you're taking the notes, not just writing them down. Your practice problem for the night, you're going to solve this system of equations, okay? And you're going to describe it. So you're going to solve and describe. That's using your inconsistence and consistence and all that kind of stuff. The system x minus y equals 2, and 3y plus 2x equals 9. Now you may need some graph paper or you may need to make a grid beyond this little square. Do the best you can in showing your work on that space. If you need more space, you can attach it, okay, and then we'll go from there. We're going to treat these practice problems like we do with your homework problems. We just want an effort, but the more effort you give, the more feedback we can give to you on one problem, helping you figure out that mistake. So this is your homework, the one problem. You finish the notes, and we will actually do the assignment to this in class when we come back from Christmas break.